Okay, welcome back. We are going to start the chapter 1. And this packet is for chapter 1, section 1 and section 2 together. And we will cover objectives 1, 2, 3, and 4. And we are going to learn points, lines, and planes. Those are the basic figures that we need to learn to do geometries. So the first problems, here's the warm-ups. I want you to stop the video, and for this one, using without any measurement, think about which one is longer, the RS or TU, just by visually. And also think about which one is longer from A to B or A to C. Stop the video and come back. Okay, how many people thought that TU is longer? Oh, and how many people thought that these are the same lengths? Let's just measure and what's the difference. Okay, so the RS is about a little bit less, 1/16 less than 2 inches. I don't know if you can see, but you should try this with your ruler. And the TU is 1/8 shorter than 2 inches. So that means the RS is actually longer. So this, even though I think visually it looks like a TU is longer, but it's actually RS is longer. And what about this one? How many of you thought that AC is longer? And how many of you thought that they are the same length? Has anyone thought that AB is longer? I think visually AC looks longer here. So let's just measure. The AC is exactly, not exactly, it's 1/8 shorter than 1.5 inches. And BA is 1.5, I think. Yeah, so AB is longer, right? Let's just make sure. Are they the same? No, I think AB is longer. Okay, so again, the visuals are misleading. So this is part of the lesson that when you get a problem for geometry, you often get a diagram, and you cannot assume anything unless it's told that they are the same length, so this one is longer. You cannot assume by the diagram that which one is longer or they are the same length and so forth, because we intentionally draw a diagram out of scale. Okay, all right, so let's start. Here is what we are going to cover in chapter 1. So the 1.1 and 1.2 are in this packet, and then we have 3 more packets that covers the segments, rays, and distance, and then angles, and then we learn 2 postulates, the points, lines, and planes, and theorems. All right, so let's go over the objectives for these 2 sections, okay, which is in this packet. So the first one is use term equidistance. You should write this in your packet. Equidistance means they're the same distance. Second, use the undefined terms, point, line, and plane. Number 3, draw representations of points, lines, and planes. And 4, use the term collinear, coplanar, and intersections. Okay, so this packet, this section has a lot of definitions. Okay, so let's start with the first This was in section 1.1, okay? So this is another little lesson to realize about how the geometry problems are structured and what you have to pay attention to, okay? So suppose that you are partners in a game in which you must locate various clues to win. You are told to pick up your next clue at the point that is as far from the fountain as from the oak tree. So the point have to be the same distance or equidistant from the fountain and tree. And it is 10 meters from the flagpole. So the 10 meters from the flagpole. So you located the point X right here, which is equidistant and 10 meters from the flagpole. But you grumble because there simply isn't any clue to be found at point X. Then Pat realizes that there may be a different location that satisfies both requirements. Okay, so you stop the video here and trying to spot the other location that may satisfy both 1 and 2. Okay, did you do it? Don't continue the video unless you've done it. Okay, so, all right, so how do we find the other spot? Have you found the other spot? Is it over here? Over here? Over here? Over here? Did you find the other spot, or you think there isn't any other spot? Okay, so let's look at here. We have to find the spot that is 10 meters from the flagpole. So let's just get a compass and measure this 10 meters, right? And then draw a circle. All right, so you know that any point on this circle is 10 meters from the flagpole, right? Is there any other points on this circle that is distance from the fountain and tree are the same? Think about it. Is there? Well, is it equal distance here? No. Is it equal distance here? No. Is it equal distance here? No, this is closer, that's 4. What about somewhere around here? What about somewhere around here? Does that look like equal distance? Yeah. So if we draw more or less a straight line, perpendicular line actually, to the point that connects these two lines, and find this spot, that looks more or less equal distance to the tree, doesn't it? That makes sense? So there was another spot over here. Okay, so in geometry, you cannot assume there are multiple ways to construct or come up with answers, not just one. That makes what geometry hard, because there are more than one right solutions. Okay, all right, so that was the lesson for objective 1, and also to use the term equidistance. Okay, so let's go into the definitions. Oh, let's just sum up here. All right, so just fill these blanks, okay? The game discussed above involves points and distance. Points and distance. When you approach the game systematically, you use lines and circles. Understanding the properties of geometric figures like this is an important part of geometry. The rest of this chapter will deal with the most basic figures of geometry. So here we go, the objective 2, 3, and 4. The points. Each dot on a television screen suggests the simplest figure studied in geometry, a point. Although a point doesn't have any size, okay? The point doesn't have size. It is often represented by a dot that does have some size, because you have to draw it has a size, but in geometric terms it doesn't have a size, okay? It's just the concept of point. you usually name point by a capital letters, okay? Capital letters. Do not use small letters. You're gonna get confused if you use small letters. Small letters are reserved for other things like lines. Points A and B are pictured at the right. So these, like the, you know, the color dots in TV, these are points. All right, and then these points, A and B, these are the points. Remember, there's no size, okay? All right, lines. All geometric figures consist of points. One familiar geometric figure is a line, which extends in two directions without ending. Although a picture of a line has some thickness, the line itself has no thickness, just like no size. The line is a collection of points, so there are infinite number of points over here. And that's why, since the points do not have any thickness, the line has no thickness, okay? And then it extends infinite to the both directions, okay? Often the line is referred to by a single lowercase letter, okay? So lowercase letter is reserved for lines, like line L. This is lowercase letters, such as line L. If you know that a line contains the point A and B, you can also call the line AB, and you use this line right here. The arrows on both sides, that's a line. Or line BA. Okay, line AB and line BA are identical. It doesn't matter which one you say first. Okay, here's a plane. Okay, a geometric plane is suggested by a floor, wall, or tabletop. Unlike a tabletop, a plane extends without ending and has no thickness. Okay, so even though this is drawn like the contained area, the concept of plane has no ending. It's continuing on direction infinitely. Okay, and think of it this way: the line is a collection of infinite points, right? The plane is a collection of infinite number of lines. Okay, so there is no thickness. Has no thickness. Okay, although a plane has no edges, we usually picture a plane by drawing a four-sided figure as shown below. We usually draw like this, even though that doesn't mean that this plane ended here. We often label a plane with a capital letter, plane M. Okay, undefined terms. In geometry, the terms point, line, and plane are accepted as intuitive ideas and are not defined. These undefined terms are then used in the definitions of other terms, such as those at the top of the next page. Okay, so when I ask you on the quiz or test, list 3 undefined terms in geometry, then we are talking about point, line, and plane. And these, we cannot define them. We have to accept it as what we understand as what point, line, and planes are. And once we accept this as undefined terms, we can use line and points and planes to define other things. Okay? All right, collinear and non-collinear. The space is the set of all points. Collinear points are points all in one line. So these points are lying on one line, right? These are called collinear points. And these 4 points, you can't draw one line that goes through all points, right? So these are non-collinear points. But if I do this, these 2 are collinear. These 2 are collinear. These 2 are collinear. And these 2 are collinear, and so forth, right? These 2 are collinear. You can have 2 points. 2 points can always be a collinear because you can always draw a line between 2 points. But these 4 cannot be collinear at the same time. Okay? And here's the back. Coplanar and non-coplanar. Coplanar means the points are contained in one plane. Okay? So these points are on this plane, so these are coplanar points. Okay? These 5 points are non-coplanar because they don't belong on the same plane. However, these 3 are coplanar and these 2 are coplanar. Okay? Words used to describe relationship between points. Okay. A is in line L, or A is on line L. I think on is a more common term to use. L contains point A. L passes through A. These are all ways that we describe these two relationships of line L and point A. Line L and line H intersect at O. L and H intersect at O or in O. I think at O is a more common way to use it, okay? O is the intersection of line L and line H. Okay, here it is. Line K and point P are in plane M or on plane M. A plane M contains K and P. Line K and point P. Line J intersects plane M at point P. The point P is the intersection of line J and M. These are different ways to say it in the problems. Or means it's pretty intuitive, right? Plane M and plane N intersects in line XY. That's the line. Two planes intersect in a line. Okay, so these two planes intersect in line. When we say line XY, it's a line that extends infinitely, right? And then you have these two arrow signs here. Line XY is the intersection of plane M and N. Line XY is in M and N, because this line is contained in both lines. It's in M and L, M and N. M and N contain line XY. Okay, so those are all the definitions, and here are the practice. I want you to do these, all of these. Try them. And okay, you try on odds right now, and so you stop the video and try all odds, and I come back and do a couple of these with you. Okay, so hopefully you finished. So I'm gonna do maybe 3 from here, and we do the evens in the class, and these problems on the next 2 pages we are going to do in the class. Okay, don't worry about these. Okay, we're gonna do these in the class. All right, so let's do number 3. T, O, and R are collinear. Here's a T, here's a O, and there's R. Are they collinear? Can the line go through all 3 points? No. So this is no. What about T and O and R being coplanar? Do you think they're coplanar? Yeah, because it's on this plane M, right? So they are coplanar but not collinear. All right, number 7. R, X, O, and Y are coplanar. R, X, and O are coplanar. Are they coplanar? What did you think? I think a lot of you said no, because it's not on the plane M, right? But think about this. There's another plane that you can draw like this, and then these 3 points are on the plane, right? Let's call it plane N. These 3 points are coplanar in plane N. So this is a yes. In fact, the 3 points are always, oh, and then here the line, wait, Y. R, X, O, and Y. Yeah. So this is the line that contains in this line, and there's another R. So this is coplanar, and X, O, and Y are collinear, right? So with the collinear points and another point outside of the line, there's always a plane that can go through it. Okay, so that's a yes. And let's do 19. Name the intersection of planes A, B, F, E, so this plane right here, and B, C, G, F. B, C, G, F here. By the way, when we name these planes by the points in alphabets, you have to go in order like this. You can go either counterclockwise or clockwise, that doesn't matter, but you can do this, A, B, E, F. You can do that. You have to go A, B, F, E, or A, E, F, B. You can start from any point as long as you go in the circle. Just don't skip the points like this. The same thing here, okay? So you remember how two planes intersect? The two planes intersect in a line, right? So this is the line. So the intersection of two planes is line BF, okay? So that's the end of today's video. Make sure you complete the survey, and I will see you tomorrow in class.